Hi, this is Rusty with Sagacity All-Stream Fabrication Engineering, and today we're going to shoot the first of many videos in our Basic Tech series. Today we're talking about pressure gauges. A Bordon tube gauge that we're going to be talking about today was developed in 1849 by Eugene Bordon, a French watchmaker, who came up with the idea of putting a tube in a curled fashion and imposing a pressure on it. We impose the pressure through the process connection here, and in a second I'm going to take the face off, better known as the dial, and we're going to look at that Bordon tube and the inner workings of the gauge. Here you can see the Bordon tube, the calibration link, and the gear mechanism that actually drives the pointer, called the rack and gear. This is how you can calibrate a gauge and adjust it for a specific range. The pressure port, better known as the process connection, is located here and is tied into the Bordon tube via a weld joint here. The curled part that looks like a pigtail is the Bordon tube itself, tied through the calibration link, the rack and gear, which is tied to the pointer. As the pressure is imposed upon the Bordon tube, it tries to straighten out. It moves the pointer around the dial, and that's how you get your mechanical gauge pressure reading. Now, all of these components have to be specified when you are figuring out what type of gauge you need for your application. The pressure port can be stainless, brass, plastic for low pressure applications. In most cases, for process applications, you'll use stainless steel. You can have a bottom connect or a back connect pressure port for the Bordon tube. And then you have different case sizes, starting at 1 inch, 2 inch, 2.5, 3 inch, 4 inch, up to 6 inch. And usually the larger the dial size, the more accurate the gauge. The larger the Bordon tube, the more accurate the movement through the range. The smaller the gauge, the less accurate. Typically plus or minus 10% for small gauges, all the way through plus or minus half of 1% for 6 inch gauges. That's a general rule of thumb. We suggest you talk to the manufacturer of the gauge that you're going to buy to verify those numbers. We move to the Bordon tube. Typically those are going to be stainless steel no matter what your pressure port connection is. Your case material is usually stainless, but it can also be phenolic, it can also be brass, and you'll see that we have a plug in the top. In some instances, especially in high vibration applications, you can liquid fill this case, typically with glycerin, and that will dampen the movement so that the movement gives you an accurate pointer registration on the dial, even in high vibration. The glycerin's there only to dampen the movement in those applications and is not really needed if you're not going to be in a high vibration application. When specifying your process gauge, you'll need to know the size of that connection, the material of construction of that pressure connection, whether it's going to be plastic, which we don't recommend for industrial applications, brass or stainless, or in some cases exotics like titanium or hastelloy. And then we need to know our case size. Typically the larger the case, the higher the accuracy of the gauge. That can typically be metal or phenolic case in industrial applications, but for utility gauges there can be plastic cases as well. If you have a stainless case or phenolic case, it can be liquid filled for high vibration applications. Typically you want to liquid fill with glycerin to dampen the movement. You can have a stainless case, a phenolic case in those applications. Typically you wouldn't liquid fill a plastic case. Now, to specify the gauge, you also need to know the range. So what's your measurement range? Typically you want to make sure that your gauge is going to operate in the middle half of its full range for the best accuracy. At the very low end, you're not going to get very good accuracy because the Bordon tube hasn't stretched enough. And at the upper end, you'll be stretching the Bordon tube to its limits. So you want to make sure that your gauge operates in that top quadrant when you specify the range. If you're going to be 0 to 100 pounds in an operating range, you may consider a gauge that's got a 0 to 300 pound range. That way you're going to be operating in that top quadrant or the high accuracy portion of the gauge. Thank you for watching today, folks. Rusty with Sagacity All-Stream Fabrication Engineering. This has been our Basic Tech series. If you would, like and subscribe below to follow us and find more informational videos in the future.